y equals log base 2 of x. To graph this, what I got to think about first is when I'm trying to do log base 2 of x, I'm going 2 to what power equals x. So x needs to be different powers of 2. So that's how I'm going to choose it. So my x values, I'm going to start at 1/8, and then I'm just going to double as I go up. So 1/8, 1/4, 1/2, 1, 2, 4, and 8. So all of these x values are powers of 2. And now I can figure out log base 2 of 1/8 is -3 because 2 to the power of -3 is 1/8. Log base 2 of 1/4 is -2. Log base 2 of 1/2 is -1. Log base 2 of 1 is 0. Log base 2 of 2 is 1. 4 is 2. 8 is 3. And now we can plot these points. When I try to plot 1/8, I'm just estimating something really close to the y-axis, and then 1/4, 1/2, 1, then it's easy. 2, 4, and 8 are easy to get those last few points. Okay, you can kind of see it now where an exponential, so an exponential and a log being inverses, it's useful to remember because what happens is the asymptote for an exponential is the x-axis, but x and y switch for inverses, so the asymptote for a log is the y-axis, so it's a vertical asymptote. So there is the vertical asymptote, which is on the y-axis, and it has the equation x equals 0. So that's the basic graph of a log. So where an exponential comes along the x-axis and then takes off up, a logarithm starts along the y-axis and it comes up and then it heads off to the right. So when the base is between 1 and infinity, basically, any base that's bigger than 1 always has this same basic shape, okay? The logs, those 3 points are kind of always what it is. It's always going to go through 1, 0, no matter what the base is. 2, 1, so it's always the base and then 1, and then the reciprocal and -1. Those are always three key points. The domain of this log is x is greater than 0. The range of every single log that we graph will always be y is all real numbers.